Hello, 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 hello. Cool. So what happened is the camera gave up for some reason. So I have now connected an external camera, webcam, and then the audio levels are pretty bad. When even if I keep it very nearby, this mic isn't working that great. So I need to figure out a way. So I think the reason why streamers have a mic which sits in their mouth is maybe that's why the audio is better because I kept it here, it didn't work. The audio levels were the last 1 hour which I recorded, the audio level weren't great. One few of my friends came into the stream and they let me know that the audio levels were low. So and then I figured it out. So that's why. So I'm just figuring it out. It will take a couple of days, but no, I will get it right. So I will continue where I left. I was understanding about objects in Java. So if you're seeing for the first time, I am now reading. I'm going through this Java roadmap.sh, and then from this I figured out there is an official Java docs, and then I'm now correlating what's in this docs with what I've learned with C++. Almost the concepts are very similar, so I'm trying to correlate and understand the docs, and so I'm cruising through it. And so, whenever I am struck at somewhere, I'm just coding it out. Like I've coded a constructor implementation to understand what exactly is going on, and then I wrote a simple make script to know just run the Java code, compile and run the Java code, and that's it about the last 1.5 hours which I was doing. Until and unless I keep my mic near my mouth, and I think everything is fine. But I think around the time of 20 minutes, my camera gave up last time. So I am hopeful that this time. So there is a two video device. One is the external camera, and other is the. So I will for now I would just delete this up. So that now I don't know why the webcam is blinking, but so now this is the screen record. This is my external camera. This is my mic, and this is the output from. Suppose if I play a song, or you can hear the typing sound. It's from the external audio. So that's the current setup now, and then I have set up few hotkeys to swap between my external monitor and then my original monitor. And then suppose if you want to just have a video cam view, and I have set up few hotkeys here, and that's it. I wanted to figure out how is the how long it can stream well. Let's see, and then I will figure out what are the mistakes and solve in the upcoming days. My goal today was to stream from like 9 to 12, but since I've lost an half an hour to 45 minutes, I'm going to stream from until 1 and see. Yeah. So class provides blueprint for object. You create an object from a class, and each of the following statements taken from the create objects and assigned to the variable. This is fine. This is all fine. The new operator instantiates a class by allocating memory for a new object and returns a reference to the memory. It's a single postfix argument. Okay, a call to the constructor. The new object returns the reference to the object created. The reference is usually assigned to one variable with the appropriate type. Yeah, okay. Fine. So, this class contains a single constructor. You can recognize a constructor because its declaration uses the same name. Okay, and it has no return type. Okay, fine. So we have the original one. When we call the constructor, it just assigns the value and it gives us the pointer to the object which is being created. Okay, GC. Because I understood what object is good enough. Some object oriented program that you keep track of the objects you create and that you explicitly destroy them when they are no longer needed. Managing memory explicitly is very tedious and error prone. So okay, this is very similar to Go. So here you do the you create some object, and when you come out of that scope, and the garbage collector makes sure that it kills the object. Go does this as well. So the Java runtime deletes the object. Okay. Yeah, obviously. So if there is one when somebody is referencing that object, the garbage collector waits because since there is some reference to the object, and if an object is orphan, that is there is no reference at all, at the time the garbage collector figures out that since nobody is referencing it, I would kill that, drop the reference. Okay. Okay, cool. Understandable. A method returns to the code that invoked it when it completes all the statement, reaches a return statement, and throws an exception. Occur first. To declare methods return type. Okay. Any method declares void, does not return a value. It does not need to contain a return statement, but it. Okay. Okay. Cool. So this is all bare minimum stuff. This is okay. Returning a class or an interface. In this, if the session confuses you, skip it and return after you finish the session on interfaces and inheritance. When a method uses a class name as a return type, such as okay. Each constructor initializes some of the more variables. Okay, this constructor provides a default value for any member variable whose initial value is not provided by the. For example, the no argument constructor created at 1x1 with coordinate 0, the 2 argument calls the 4 argument constructor. Okay, I understood. Interesting. Finally, access specifiers. Access level modifies determine whether the outer class can be particular field or okay. At the top level, public. At the member level, public, private, or protected. Can be declared with a modifier public, in which case the class is no modifiers. Okay, so even this is similar to C++ class. It is private by default. It is visible only within its own package. Cool. At the member level, you can use public, private, or protected by its own class. So protected modifier specifies that can be accessed within its own package. In addition, by a subclass. Okay. So from outside you can't access protected, but you can access it at inside the class, similar to private, but even a subclass can access it. Interesting. I understood. So always have everything as private, and then avoid public fields except for constants. Okay, so every time the field is private. Okay. Finally we have static here. Okay. Every instance of the classes share a class variable, which is one field located in the memory. Okay, I understood. So this is the example which we tried a while back. We had a nested class which is not static. So to access that will be something like an inner class. So if we wanted to access something in the inner class, I need to first create the object of outer class, and then with that object we need to reference the inner class. But if I use static directly, I'll be able to directly reference it from reference it because it scopes throughout the class. So an inner class with an instance of this enclosing has direct access to the objects, methods, and fields. Correct. Because the inner class is associated with an instance, it cannot define any static methods itself. Okay, correct. The object that are instances of an inner class exist within the instance of the outer class. Okay. Instance of the inner class can exist only within the right, that's exactly what I told. If I wanted to access something in the inner class, I need to go via the outer class. So I need to create an instance for that outer class, and using that instance I need to be referencing this inner class. You must first initiate the outer class. True. Okay, correct. Understood. This is the differentiation. So if you would have added static here, what happens is I'll be able to access it. The level of it will be very similar to that of outer class. So I can just directly create an object for inner class and then use it, and I can access all the variables. And as a differentiating factor, you have encapsulated the variables as outer and inner. So here that is a outer field, that is a static outer field. Okay, there is a inner class which has an this one, it's a function call which just prints to value. Okay, which is private. And then there is a static class okay. I will create a new object for the outer class, and using the new object I will create an object for the inner class, and then with the inner object I will be accessing this. Correct. So I will be getting outer field, static outer field. Correct. And then for static nested class, I don't have to go via that route. I can directly create an object. So I directly create an object, and what I do is I pass on this outer classes method there, so it will be outer field, static outer field, correct. And then for top level class, where is top level class? There is a separate top level class. So to act, even it takes outer class here. So this is the trickier part. So I'll create a new object for top level class and then I'll try to access it, because it will still be the same, correct. Note that the static nested class interacts with the instance members of the outer class just like any other top level class. The static nested class cannot directly access outer field because it is an instant variable of the enclosure. Okay, yeah, makes sense. Okay, just because it is inside, I can't. Just because this is inside, I can't directly go reference this one. Even it needs its own object, and I need reference the value. If there is one in, okay, that is fine. So, but for accessing alone, I can just directly come and access it. So if a declaration of a type so this is a class, this is a class first level, and it has x is equal to 1, and it has a method which prints x shallow test dot this dot x. So we are trying to access a level up. So if a declaration of a type is in a particular scope, has the same name as another I want to test this out. One second. So I'll create shallow test dot java. Oh, it is shadow. Rename. Here I create a new object for shadow test. So okay, first let me see what is the output here. So here I'm trying to call this method with a value 23. So x is 23. This dot x will be 1. Most importantly, shadow test dot this dot x will be 0. Assume this is as y. Is it possible to directly access y? Suppose y is 10. Is it possible to directly access y without? Yes, it is possible, but I can't. So what happens if I do x here? Because there is another variable of x here, I can't directly access it. So this will be again 1. Uh, 23. Oh, sorry, 23, because I am passing on 23 here. Okay, cool. So the class which I am referencing dot this dot x. Okay, understandable. Let me go and see what's the today's lead code problem and try to solve it. So let me switch on the stopwatch and start reading the problem. You have two soups A and B, each starting with NML. On every turn, one of the following four serving operations chosen at random, each with a probability of 0.25, independent of previous turns. Pour 100 ml of type A and 0 ml. Okay. Each has. Note that there is no operation that pours 0 ml of A number. Okay. The amount of A and B are poured simultaneously during the turn. Okay. If an operation asks you to pour more than you have left in the soup, then pour all the remaining. Return the probability that A will be used below B plus half the probability that both is. What is this? N is equal to 50. Okay. What is the probability? A will be used before B. So if we perform either of the first two serving operations, soup A will become empty first. Empty at the same time, correct? Yes, so the total probability of A becoming empty first plus half the probability that A and B will become is 0.25 into so each has probability 0.25. So 0.25 into, if you form either of the operations, soup A will become empty first. Okay, probability of A used up first is 1. If you use 75 ml of is also 1. If you use 20 is 50-50 chance. Okay. So we need to find two probabilities here. That is, probability of A is used up before B, and then probability of both soups are used at the same time. Half the probability. So suppose we have 150 ml, we can perform either of the first two serving operations. True. We perform the third operation, it will be empty at the same time. True. We perform the fourth operation. Correct. So this is half. If we perform the first serving operation, soup A will become empty first. Correct. So that is 1. If we perform the second serving operation, we keep pouring 75 ml. More than you have. Okay. So if we perform the second serving operation, A will become empty on performing operation 1, 2, 3. I don't understand. If we perform the second serving operation, A will become empty and 1, 2, 3, and both A will become empty. Okay, so we do 75. Suppose it is 100 ml, we do 75 ml first, and then I will have 25 ml and then 100 ml. So I will do. Okay. Cool. There is no operation that pours 0 ml. The amount from A and B are poured simultaneously. The operation asks you to pour more than what you left in the soup. Pour the remaining. Okay. So in the first case, suppose I have 50 50A, 50B. Wait a minute, I can. So as per the rules, pour 100 ml of type A, okay, 75, 50, 25. So since I have 50, I can do first things. I can do, if I choose A, I will pour all the 50 ml and there will be 0 ml. So probability of this is 1. So 70 also, it will be 50 and it is throwing 55, so this will get finished, so probability is 1. So 50 50, so this that is 0. That is also 0. So this is 2 into 0.25 plus the other case is at the same time. So at the same time, this is not possible, this is not possible. A and B 50 50, so that is true, that is 1. Finish at the same time. This also is not possible. Cos 25 will be remaining, so this will be 1 into 0.25. So calculator, 0.25 into 2 plus 0.25, which is half of it, sorry. So that is 0.5 into 0.25, 0.5 into 0.25 plus 0.5 so 1 plus 1, this is 1 and this is 1. Which is 0.5 plus sorry 1 I am getting 0.75, half the probability of both this. So that is 0.25 by 2 plus 0.5, 625. Yes, correct. Let's take the second example. you perform the first serving operation, obviously, always this is 1, because whatever the case may be, this is 1. We can forget about it. Take this case. We have 100 ml, we take 75 ml, and then we take 25 ml out of it. So we again have, initially we have 100 and 100. The moment we perform B, we have about 75 and then 25 and then 75. We perform up, if we 1, so first I will do so if we perform the third operation, A and B will become if you perform the second serving operation, A will become empty on performing the operation 1. Okay, so I do this, which is 0.25, and then I have perform 1, okay, understood how to do this, solve this problem. So for the second example, we have 100 100. So we have four choices here. Either you can choose choice 1, choice 2, choice 3 or choice 4. If the end goal, if a equal to if a equal to 0 and b equal to 0, at that time I'll just half that probability and add. Let's take for the first example 50 comma 50. If I choose the first option, I will get 0.25. If I choose the second option, I'll still get 0.25. If I choose the third option, I'll get 0.125. And if I get the fourth option, is 75 here. So if b becomes 0 and a is not 0, and then I will return 0. Okay, cool. So here so first we have four different states here. So we need to run through four different combinations here. So that will be the starting point. So four different starting points. I'll just add the four possible constraints as a pair. So 100 comma 0, 75 comma 25, 50 comma 50 and 25 comma 75, and then that will be always the initial state, and always you have four different options to pick through.